Okay, so we are still doing u substitution, but this has a definite integral. So this is a definite integral with some limits. Okay, so they want you to evaluate. So let's just do the same thing that we did before. You're still going to figure out what the integral is. So go ahead and figure out what is u, what is du. And just leave it there for now because we're going to do something with this problem because it's a definite integral. So go ahead and figure out what is u, what is du. All right, let's see. Rachel, what is u? And then what is du? Okay, 2x dx. Okay. So now at this point, we could solve this integral, plug it back in, and then figure out what the integral is, plug u back in, and then evaluate. But that is an extra step we don't need to take. So what we want to do is evaluate this integral in terms of u. So normally what you would do is, you do u and du and blah, 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 and then at the very end you have like u something, 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 and then you put it x back in, you evaluate it from 1 to 3, right? That's what you would do. But that is an extra step we don't need to take because we could evaluate this in terms of u. To evaluate this in terms of u, this limit has to change because you're not doing x anymore, you're doing u. So the question is, what is the same limit in terms of u and not x? All right, so we need to figure this out. So on the side, what is u equal to when x is 1? Maybe I can just do it this way. I don't have a better way of writing this. So we are evaluating from 1 to 3. So then we are trying to change the limit so that this is in terms of u. This 1 is in terms of u. The lower limit is in terms of u. So when x is 1, what value is u? 2. So it's just substitute in, right? So 1 squared plus 1, this is 2. Okay, the upper limit is x equals 3. So when x is 3, what number is u? 10. Okay, so when we evaluate this in u, this whole integral changes from 2 to 10. So it was 1 to 3 when it's in x. It's 2 to 10 when it's in u. Okay? Okay, so let's write this integral. So I don't want this 2 in the du, so I'm going to do 1/2 du equals x dx. 1/2 u du. Oh, thank you. All right, so now what you want to do is evaluate this integral from 2 to 10. Okay, so do the same thing you did before with the indefinite integral, but this time you're going to evaluate from 2 to 10. So go ahead and figure out what this number is. Okay, let's finish this problem. So this integral is 1/8 u to the 4th, evaluated from 2 to 10. Okay, and this answer is 1248. No, we don't need to plug x in because we already figured out what it is in u. We're just going to forget about x. You could do an for x, but you're just taking an extra long step. All right, definite integral in u sub. Sorry. Okay, so definite integral. If g prime is continuous on a and b, a to b, sorry, and f is continuous on the range of u equals g of x. Okay, so basically what we're doing is trying to do some u sub. Then the integral from a to b of f of g of x times g prime of x dx. Okay, notice this is just a chain rule, right? F has g inside, and then g derivative, which is like a chain rule. So basically, we're trying to make g, the u. So this becomes an f of u, or just u, depending on the power, and times du. So basically they're saying this whole thing, this integral of this whole thing, where we now have a definite integral from a to b, can become g of a to g of b of f of u du. So we're changing from x to u, and to do that, we need to also change the limit as well in terms of u, and u in this case is g. Does that make sense? No, yes, no. Okay, so this part is just the problem, like a normal problem. They're saying that if you want to change this problem that is in x into u, then first of all, change this u part, which we've been practicing for 2 days, but also remember to change your limits. And how does the limit work? The limit has to do with g. G is u. Okay, g of a and g of b. So what is a in terms of u? What is b in terms of u? That's what it means. Okay, let's try another one. This one, they already gave you the u. They're telling you what u should be. Okay, so u is 3 minus 5x, or you can probably figure that part out. But they want you to evaluate using just u, so that means you need to change the limit from 1 to 2 to something else. Okay, go ahead and change the limit. This one is a little tricky, so I'm going to help you finish. But go ahead and figure out u, du, change the limits a and b into something with u. All right, let's look at this question. So u is 3 minus 5x, du is minus 5 dx. So that means negative 1/5 du is dx. Okay, now let's do some substitution. So when x is 1, u is negative 2. Okay, when x is 2, u is negative 7. Okay, now we need to plug it back in exactly. So when x is 1, u is negative 2. When x is 2, u is negative 7. This is negative 1/5, 1 over u du. All right, can we integrate like that as is?
Yes. 1 over u squared.
Oh. Sorry. So the limit is from negative 2 to negative 7. Can we evaluate in that direction? No, we have to put the smaller number on the bottom, right? So what do we have to do to switch the limit? Put a negative in front. Okay, so this becomes negative, and then negative 7 on the bottom, negative 2 on the top, negative 1/5, 1 over 2 1 over u squared du. Okay, so this is very important. When you plug back in the limit, you know that the smaller number has to be first. So we'll have a tendency to just automatically switch it. But remember, the limit didn't change. The numbers have to correspond in their own position. You have to change it later with a negative in the front. All right, so go ahead and finish evaluating this. So this one, the integral is negative 1/5 u to the negative 1, evaluated from negative 7 to negative 2. The answer is 1 over 14. It has a lot of negative signs, so you have to be very careful with evaluating it. All right. Let's try another one. Huh? No, I think it's positive 1 over 14. Okay, let's try another one. This one here. Okay, let me know when you're done. Do you guys need me to do this or just give you the answer? Okay, all right. U is natural log x. Du is 1 over x dx. So then When x is 1, u is natural log 1, which is 0. When x is e, u is natural log e, which is 1. Okay, so this is from 0 to 1 of u du. Okay, that is u squared over 2 from 0 to 1, so that is 1/2. All right, the last part is just kind of giving you some more kind of like integral tricks. First, we're going to integrate by looking at symmetry, because if there is a very apparent symmetry of that function, you can do some tricks so that you don't have to go through a lot of work. Okay, so suppose that f is continuous on negative a to a. Notice that it's negative a to a, meaning the numbers are the same, and then it's kind of maybe we're looking for some kind of symmetry. So negative 2 to 2 or negative 1 to 1, some kind of negative a to a. If f is even, what does even mean? Even function, how does it look like?
F of x equals f of x.
Yes, so symmetrical across the y-axis, f of negative x equals f of x. So basically your graph looks like this, like it's the same if you fold it across the y-axis. Let's say that you're looking for this integral from negative a to a. So this is negative a and this is a, and obviously they are equal distance from the origin. The question is, what is this integral? Well, this area is the same as this area, right? It has to be, right? Because it's even, it's the same. It's a mirror. So this, we can just say it is 2 times from 0 to a of f of x dx, because it's even. We know that it looks exactly the same, so left and right, so we can cut it in half, do 1/2 of the area, and then multiply by 2. All right, second case, second symmetry. If f is odd, what does odd mean?
Symmetry across the x-axis?
No.
That would be easy.
X.
Equals to negative f of x.
Okay, f of x equals to negative, I'm sorry, f of negative x equals negative f of x, but how does it look like as a graph? No, that would be an inverse function. Turn it, how many degrees?
180.
180. Okay, so, huh? Oh, sorry. I thought you said 90. Thank you. Okay, so something like this, right? This would be an odd, excuse me, function from negative a to a. So this is negative a, this is a. So the question is, what is this integral? 0. So this part is positive, and this part is the same but negative, so they add up to 0. Okay, so if you already know how the function will look like, you can use this trick. Or a lot of times they would just say, given that this function is odd, or given that this function is even, you can basically know that they want you to use this trick. Okay, so let's look at this question. Negative 2 to 2 of x to the 6 plus 1. So obviously, I need you to figure out if it's even or odd. Okay, and let's say this is on the multiple choice question on the AP test. You have no calculator, so you cannot check whether this is even or odd. I mean, you could take the integral and just evaluate. Or you could just try to see, is this the same? Just think in your head, if I put a negative x in here, will I get the same function out? Yes, because it's an even power, right? So then what can you do to make this a simpler question to do? 2 in the front, and then the limit changes from negative 2 to 2 to 0 to 2. Okay, so go ahead and figure out the answer. All right. The answer is 284 over 7, which is about 40.571. Okay, let's try another one. You guys done copying? Good? Okay, next one, this one. Tangent over 1 plus x squared plus x to the 4th. That would be impossible to integrate. So that means look for the trick. So odd or even? Odd. How did you know it's odd? Okay, because I just did even, so I had to give you odd. Okay, so basically think to yourself, if I put a negative x in there, is the whole function going to become negative? Well, this part, no. This part is going to keep staying positive. This part, you have to remember tangent is a odd function, okay? If you couldn't remember that tangent is an odd function, you could always try putting in some number that has a sign, right? So like maybe try tangent negative 1 pi over 4 and see if you get a negative of that number, something like that. Or just remember that tangent is an odd function. So this is odd. So then what is the answer?
0.
0.